this video, I'd like to walk you through the unit circle and show you that the unit circle really is as easy as 1, 2, 3. Let's get started. The unit circle is as easy as 1, 2, 3. First, number 1, we're going to look at what the unit circle is. Number 2, we're going to look at how to use the unit circle. And number 3, we'll look at how to derive the unit circle, or I'd like to name it this: derive the unit circle without letting it drive you crazy. Don't you want to laugh at that? Well, okay, maybe you don't want to laugh at it. Maybe I think it's funnier than you are. But here it is. Here's the unit circle. What is it? Here it is completed. At this point, as you're studying Calculus 1, you should already be familiar with this unit circle, though you may need to review it. And I want to encourage you to memorize this process of how to derive the unit circle. Now, if you simply memorize this each time you're going to have a quiz or a test over it, that's not going to serve you as well as truly understanding how to derive the unit circle. But this is what it looks like. And what is its purpose? What we have here is a tool that allows us to easily identify that the let's say the cosine of 30 degrees is the square root of 3 over 2. Or we can easily find from this unit circle that the sine of pi radians is 0. Or we can see from this unit circle that the cosine of 330 degrees is the square root of 3 over 2, or so on. So it gives us what we're going to call the principal angle, sine and cosine. That's what the unit circle is. Next, how do you use the unit circle? How do we use the unit circle? We could use the unit circle to complete a chart that looks like this. We have sine and cosine of, let's say, 0 degrees. What I know from the unit circle is that the cosine of 0 degrees is 1. The sine of 0 degrees is 0. If I wanted 30 degrees, the cosine of 30 degrees is square root of 3 over 2, and the sine is 1/2. For 45 degrees, which is equivalent, by the way, to pi over 4, but the cosine of 45 degrees is equivalent to the sine of 45 degrees. So you see, if I didn't have this device, this unit circle, I would actually have to memorize all of these values. And then 60 degrees and 90 degrees, 1/2 for the cosine, square root of 3 over 2 for the sine, 0 for the cosine, 1 for the sine. I'd have to memorize each of these and then say, but wait, there's more, because I'd also have to be able to do 120 degrees, 135 degrees, 150 degrees, 180 degrees, etc., all the way around. And I'd also have to know, if I changed these angle measurements to radians, I'd also have to know that, well, the 0 radians stays the same, but pi over 6 radians, pi over 4 radians, and pi over 3 radians, and pi over 2 radians, etc. So you see, that's an awful lot of information to memorize if we had to rely on using the chart. It's much easier to do this with the unit circle. By looking at the unit circle, let me show you one more time. How do we use it? I can pick any of them. It's almost, oops, let me erase that. I could pick any of these and say, I'm going to use 120 degrees. The cosine of 120 degrees is negative 1/2. The sine of 120 degrees is the square root of 3 over 2. Because what I have here is a list of ordered pairs where we've got the x and then the y, and the x is a cosine and the y is a sine. So the cosine, the x value for 30 degrees, is the square root of 3 over 2. The y, the sign, is 1/2, and so on. That's how we use the unit circle. Let's look next at how to derive this unit circle. How do I get those values? Here's where I'm going to say it's really as easy as 1, 2, 3. Here's why. We know that 1 is less than 2, which is less than 3. From that, I could also say, well, I could divide everything by 2 and the inequality holds, right? Because 1 is less than 2 is less than 3. 1/2 is also less than 2/2, which is also less than 3/2. What if I square rooted these numerators? I still don't change. When I square root the numerators, I still don't change that inequality. Square root of 1 is still just 1. So I have that 1/2 is less than the square root of 2 over 2, which is less than the square root of 3 over 2. It's as easy as 1, 2, 3. I'm going to think of these three numbers, the 1/2, square root of 2 over 2, and square root of 3 over 2, as a small, medium, and large. Or if you're a Starbucks fan, you could think of them as a tall, that's the smallest one, a grande, that's the medium, and a venti, that's the large. Square root of a line that is a square root of 3 over 2 units long is longer than the line that's a square root of 2 over 2 units long, which is longer than a line that's 1/2 of a unit long. So I can put these in order: small, medium, large. Transfer that over to the unit circle, and you'll see that we have a long line and we have a small line, a medium and a medium, a small and a large. Let me show you this one more time in comparison to each other, and I'll use 3 different colors this time. If I looked at this pink line, notice that the pink line is shorter than this medium-sized blue line, which is shorter than this longest purple line. So this small distance, if I was looking for an ordered pair, we'd have a small x, so the small x is a 1 over 2. And then here we have a medium x, square root of 2 over 2. And this third ordered pair has a long x, square root of 3 over 2. I hope that makes sense. If not, pause the video, rewind it, go back and look at it one more time to see if I'm simply looking at ordered pairs for these points. Forget that they're on a circle. Just these ordered pairs, right? These points. I could see that this first point right here has a shorter x than this second point, which is shorter x than this third point, and so on. So what happens is, just by knowing 1/2 is the short, square root of 2 is the medium, square root of 3 over 2 is the large, I can put all these ordered pairs in. Here, this first ordered pair is just a 1, because that's a unit circle, right? X equals 1, y equals 0. Here we've got a long x, a square root of 3 over 2, a short y, so that's going to be a 1/2. Here we have a medium. Let me go back to color coding these. A medium and a medium. So if I color coded these, then we'd have the square root of 2 over 2 and a square root of 2 over 2. And then I'll close it with not color coded necessarily. And then this last one, we've got a short 1/2. So we have a short length here, and then we have a long, the tallest, we have a long, big square root of 3 over 2, right? And then finally this point, this last point, would have an x equal to 0 and a y equal to 1. You see these 5 different ordered pairs here, all in quadrant 1. And that's how we see a 1, 2, 3. Square root divided by 2. The 1 over 2 is less than the square root of 2 over 2 is less than the square root of 3 over 2. So we can name each of these ordered pairs knowing that a unit circle has a radius of 1. So this distance all the way across, the radius is going to be a 1. Or this radius all the way up is going to be a 1. And then each of these other 3 lengthed lines will either be a small 1/2, a medium square root of 2 over 2, or a long square root of 3 over 2. Let's look at the other quadrants quickly. Do you see that in quadrant 1, x and y are both positive? In quadrant 2, x is negative and y is positive. And in quadrant 3, x is negative and y is negative. Do you hear my dog Nibbler Pie? She's so excited about the unit circle that she's barking to be part of the video. Apologize for that. But we have a negative and a negative. And then quadrant 4, x is positive and y is negative. Nibbler Pie, I'm so sorry you can't see her in this video, although you can hear her. She's the cutest little thing, and her middle name is Pie because she was born on Pi Day. Can you believe that? She was born on March 14th, Pi Day, so that's her middle name. Anyhow, we've got we can see the positive and negativeness of our quadrants and how that's the only thing that would change when we go to quadrant 2. So this point right here in the middle, in quadrant 1 it was a square root of 2 over 2. When we get to quadrant 2, we see that x is a negative square root of 2, so the cosine is negative, and y, or sine, is positive. So positive square root of 2 over 2, and so on. That's the first step to deriving the unit circle. The next step to deriving the unit circle is being able to mark the degree measurements, the angle degree measurements. Our first angle is just going to be a 0 degree angle. Our second angle is going to be a 30 degree angle. I'm going to skip to the 60 degree angle because I'm just counting by 30s. 30, 60, 90 degrees. The next one, I'm not, well, I'll go ahead and draw this arrow around so that you can see the pattern continuing. 90 plus 30 more, 120 degrees, and then 150 degrees, 180 degrees. I'm just going to count up 18, 19, 20, 21, so 210 degrees. 21, and then count up 30, 21, 22, 23, 24, 240, 240, and then count up by 30, 40, 50, 60, 70, 80, 90, 300, plus 30 is 330, plus 30 more is 360, and we've gone all the way around. We can see that 0 degrees is equivalent to 360 degrees in a circle. Next, I'm going to go back and I'm going to catch those 45s. That's let me show you these blue ones. So we've got 45 degrees. Double that, so 45 times 2 gives us 90 degrees. 90 degrees plus 45 degrees would put us at 135 degrees. 135 degrees plus 45 would put us at the 180, plus 45, 225 degrees, plus 45 puts us at 270, plus 45, 315 degrees, plus 45 puts us back at 360. We could also do the angle measurements in radians. If we know that we're starting with 0 radians, and if we went all the way around the circle, that's 2 pi radians because circumference of a circle. Circumference is 2 times pi times the radius. If the radius is 1, the circumference of this circle is just 2 pi. So if I went all the way around, that radian measurement would be 2 pi. Halfway across would be pi. Halfway to pi would be pi over 2. And if we just went by halves, 1 half, 2 halves, 3 pi over 2. Now I've done the halves. Let's go back and catch half of the half. Half of the half would be a fourth. So pi over 4, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, and 8 fourths is the same as 2 pi. Now if I went a third of the way, 1/3 of pi over 2, 1/3 of, or times, pi over 2 would give us pi over 6. Let me switch colors here, and I'm going to use a nice bright green. And we'd see that this angle, and by this I mean this green angle here, is going to be 1/3 of pi over 2 radians, so pi over 6 radians. 2/3 would be 2 pi over 6, but when I reduce 2 pi over 6, I get 1/3, or pi over 3. 1/6, 2/6, 3/6, 4/6. But that's going to reduce for us to 2 pi over 3. And so on. I could go all the way around. So 4/6, 5/6, 6/6, 7/6. What am I doing? 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6. 8/6, which reduces to 4 over 3. 9/6 reduces to 3 over 2. 10/6 reduces to 5 over 3. And then finally 11/6. Let me show you that one more time. The green, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7, 8, 9, 10, 11 pi over 6. 12 pi over 6 reduces to 2 pi. And that's how we could go all the way around the circle in the angle measurements in radians. Let's tie this all together. You try it. I would encourage you to pause the video and see if you can't fill in all the degree measurements, both in degrees, and then go back to the angle measurements in radians. And then can you name each of these XY coordinates, which are the cosine and then the sine all the way around the circle. After you've tried that yourself, you could check it with these values here. And that wraps up our video. I hope that you have found that the unit circle really could be as easy as 1, 2, 3.